Okay, YouTube, in this video we're going to discuss the premises behind coterminal angles, starting with what the heck this word means. Well, let's recall when we're discussing an angle in standard position, we are discussing any angle that starts on the positive x-axis. So let's say I have an angle that just, all I know is it terminates here. The simple fact is I have not sketched in this angle yet. You don't know whether it rotates clockwise, counterclockwise. Did it go around more than once? Did it go around more than twice? It could have done any of these things at this point. We say it is ambiguous. So given the fact that it starts here and it terminates here, we often want to indicate angles that, although they're different angles, they still terminate, say, in this spot right here. And to kind of foreshadow a little bit, it's because any angle that rotates and stops here is going to make the same right triangle, essentially. But for right now, let's just kind of open up the door to the fact that it could have been this angle, or it could have been this angle right here. Okay, so I want to discuss the difference between these two angles here. No, literally the difference between these two angles. Because the fact is, I don't know what they are, but I simply can tell you this, that the first angle, and if I wanted to call this first angle, I'm going to call this a theta, and we'll call the second angle a phi. I think it is fair to say that phi, whatever it is equal to the original theta where it terminated, and what I did was I added on 360 degrees to it. So this, when I talk about the difference, I want to talk about the difference. Basically, if I wanted to find a coterminal angle with another angle here, all I need to do is add on or subtract off here the two angles. And actually, this would be, if we were to subtract theta from both sides, is what I mean by difference, if you didn't catch my stupid math joke. But basically, if you take off the bigger angle minus the smaller of the two angles, it should be a difference of 360 degrees. So the simple fact is, if you want to find coterminal angles, all you really need to do is add on 360 degrees or subtract off 360 degrees as many times as you like, and you would have to have two angles that terminate in the same spot. So first things first, two angles whose terminal sides in the same place are said to be coterminal angles, and that's if they're both in standard position. So, we say an angle coterminal with a given angle can be found by adding or subtracting multiples of 360. Sometimes you'll even say that, given a 60-degree angle, you could conceive of this as being maybe right here, 30 degrees shy of 90. But if this was 60, we could basically say this. We could say plus or minus 360 degrees times n, where n is an integer. You'd still have another angle that just has to land here. It could spin around again and again, but we're just adding on or subtracting off multiples of 360. So what I want to do here is this. I want to find one positive and one negative angle that are coterminal with these two given angles here. So we're going to start with this negative 65-degree angle. This is our theta. So what I want to do is I want to sketch theta in standard position. I know, first of all, that it is rotating clockwise, and it's past 60 degrees by a little bit. So I know that if I were to rotate 60 degrees, then this would be, let's see, this is negative 65. And this leftover would be 30, but since this is 65, this leftover is 25. This seems about reasonable here. So this is our theta. What I want to do is I want to come up with a positive angle that's coterminal with this. So like this would be the first angle that I would consider. And, in order to find this, what we could do is we could say, well, what I'm going to have to do is we could consider this to be like 360 minus 65. And this is just doing mental math and talking about common sense. So 360 minus a 65 would have been some positive 295 that rotates you over here. What I want to do is I want to go so far as to say, well, if I already know this angle is a negative 65 degrees, what I really could do is I could just add on 360 without having to consider this visually in the first place. So if I were to add on 65 negatives to a positive 360, I'd actually could take off the 65 here. And so we would get borrowing from the 6 here. You got a 5. And then borrowing from 3, you get a 2, and then 15 minus 6 is 9, so we get 295. And so this is the very same 295 that we found right here. So this is a 295-degree angle, but we just confirmed it visually. And if you were to talk about also visually, if we were to switch over to like a purplish here, we could go negative 65 plus another negative 360. And so what we're really saying here is take the original angle, like we did up here, instead of add on 360, we'll take off 360. So if we were to take off another 360, well, two negatives, that's just going to make it more negative. So I'm going to add these together, kind of, and ignore the fact that these are over here. And we would say that this would be a 5, 2, carry the 1, and then a 4. So 425-degree angle, and it was two negatives adding up. So negative 425 would be this angle that spun around negative 65-degree rotation, and then another negative 360. So these are our positive and negative coterminal angles. Again, I want to try this with a 495. Now 495 to begin with, that already rotates around one full time. Actually, I should choose a different color here. How about you see this? Okay. It already rotates around one full time, and then how much more? Well, we're going to have to take that 495 and subtract off a 360 from that. We get a 135. So 135 is 45 degrees short of 180, which is right here. It is 45 degrees past 90, which is right here. So we would say another 135 on top of that would be this guy right here. So the interesting thing is this is our, I'm going to label it out here, a 495 degree angle, but I want a positive and a negative coterminal angle. Or a positive, we could just say is this guy right here. And we already figured that out. That would have to be a 135. So we could also find this by taking the angle and subtracting off 360. I'm here to say that both ways are valid. This is the way I'd like to push everybody, is to just subtract off 360. And to find a negative coterminal angle, we'd have to rotate clockwise. But you see that, we'd actually have to just take this 135 and we could subtract another 360 off of it. And it'll yield another negative, or another coterminal angle that happens to be negative. So in this particular instance, 5 minus 0 is 5. 3 minus 6 we can't do, so we're going to go ahead and borrow. Actually, we've got to do this in another order. Sorry, it is minus 360 indeed, but we're going to have to subtract the 360. Oh, come on now. Above the 135. And then just call our response negative. So we get borrowing from the 6 is a 5, 10, 5. So let's see, 2, and then 2. 225. And this is negative because we were taking 135 minus 360. So we get a negative 225. This is a negative 225 here. So these are the two coterminal angles, one positive, one negative. Cheers.